Section 3.4, energy. Now, quite often when we think of energy, we think of, oh, I need that cup of coffee to get me going this morning, or I need to put some gasoline in the car so that it has the power to take me to school or to work. But something so simple as a defibrillator provides electrical energy to the heart muscle to reestablish normal rhythm. We eat an apple, or we eat a banana, or we eat some chocolate milk to get us some calories. So what is that kind of calorie? Is it a big C or little c? Well, that's a kind of energy, and we are going to learn about big calorie and little calorie. We're also going to convert between different units of energy in this section. Now, energy is defined as the ability to do work. So because of that, we need some units, some labels. So heat is the energy associated with the motion of particles. The faster the particles move, the greater the heat or the thermal energy of the substance. And that label, that unit of energy for the SI unit of energy and work, is the joule. Now, 1,000 joules is a kilojoule. Of course, we know that because of the prefix K. All right? But joule. So if we want to look at the comparison in table 3.6 of energy of various resources and uses, we can see the amount of energy in joules. So let's think about this. So the unit calorie is defined as the amount of energy needed to raise the temperature of 1 gram of water by 1 degree. Just to let you know, if you ever watch Jeopardy, almost like once a year, they will always have that definition in Jeopardy, and you gotta go, oh, calorie. Well, I'll just tell you that you need to make sure that you realize that when they're talking about that, that's a little c calorie, which is not the calorie we think of when we say that little snack size pouch of peanuts, is 300 calories. That's a different kind of calorie. That's a big C. But here we go. So the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. So a calorie in our SI units is 4.184 joules, which is an exact conversion. So we can write it as 4.184 joules is 1 calorie, or the other way around. Now, 1 kilocalorie is 1,000 calories. Now, 1,000 calories of this definition, the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius, is actually 1 calorie of what we think of calorie. So 1,000 of these little c calories make up our 1 calorie that we think of. So when we're talking here on our unit of energy, 1 kilocalorie, a kcal, is 1 big C calorie. You need to pay really a whole lot of attention to if it's a capital C or a small c. So I want to point out again, the unit calorie is defined as the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. However, when we think of something like a banana having 80 calories, it is 80 big C calories, not 80 little c calories. The point is, we think in big C calories, but these units of converting calories to joules is a little c as in calories. So pay attention to if it's a big C or little c. We need to know that 1,000 calories is 1 big C calorie, which is the kind of calorie we think of. And so a kilocalorie is 1 calorie that we think of. Now then, how many calories, notice little c calories, are obtained from a pat of butter if it provides 150 joules of energy when metabolized? So we need to convert from joules to calories. We have our formula that you need to, our conversion that you need to know that a calorie is 4.184 joules. We can use it either way. Let's see. We start with 150 joules, so that means the conversion we need to have is that 1 calorie over 4.184 joules so that the label J cancels out. Notice how we're using our unit conversion cancel out that we learned back in the last chapter. we'll keep doing this, like kind of the whole part of the general chemistry portion of this class. So when we do that math, 150 times 1 divided by 4.184 is 36 calories.